now, and we actually continue continue our practice with Arduino today. But before, I just want to discuss some formal cases. Okay, and some formal things about the exam. I have an agreement with my Latvian group that we will have an exam on 15 of June. Would you think it will be fine for you too? And I just may suggest that 15 of June at 10 o'clock we actually will have an exam. And exam is, do you hear me generally?
Yes.
So an exam will be from two parts, as we have some limited ability to work online, so offline. So we will have an exam online. It consists of two parts. It will be 20 question test, and it will be the set of tasks to be solved. They actually, you have to calculate and then pattern and the answer. So you should make calculation and provide some answers. Well, so I suggest that we will have an exam in 10 o'clock. So actually it means that the online tool for the exam will be opened at 10 o'clock. And at 14, it's Monday, at 14, somewhere about 12 o'clock, we will have a consultation before the exam. As to the topic, so is it fine with you? I hope yes. So, is it okay? More or less. So well, so let's say that we have a consultation at 14 of June, it's Monday, 12 o'clock, and the exam will be at 15 of June, from 10 o'clock. You will have a possibility to connect to the exam through the Ortus. Up to today,
Yep. I have a question, and how will be the final grade will be calculated? I mean, will it be only by the exam, or will it count the homeworks also?
I actually take into account whether the homework was submitted or not. So I just calculate that they are submitted or they are not submitted, something like that. And the final mark mainly is from the exam and the actually from the two parts of the exam. But if you have submitted all the homework that was assigned, so you will get probably additional bonus, or let's say, and on the other hand, you will not have a penalty like that. So the penalty is within ±1, no more. Yes, that's why we have still two classes before what we actually dedicate to the calculation. First of all, I would like you to review in Ortus. I already actually right. We have some kind of text with examples of how the task should be solved. So if you take a look in your Ortus, you will find at the very beginning now the problem for the course part 1. So actually this is an example of the tasks what you should, it's actually these tasks what are there, it's even more complicated than those tasks what will be in the exam. The calculation for the exam, you may look in Ortus, some exam problems. So just look at the exam problems, and they are more or less show what could be the tasks, could be these tasks for the exam. So they are very simple. If you wish, we may actually go through it on the next classes to see whether it's possible to make this calculation for you, to make possible to make this calculation for you. And please review. It's already, you already have it, and we may discuss. Just please review it by yourself and mark whether you have some question or not, and we will discuss next classes. So what is the is it fine? Have you got a solution for every task, or there was some problem? And so it's actually yes, and then it will be fine, because the task for the exam will not be much more complicated. You may take a look on the exam test example as well. The test example is only with 10 questions, not with 20 questions, but the nature of the questions is actually will be the same in the task, in the exam, but it was just a little bit more, like, like two of such type of tests. And finally, in the same, in the Ortus, when you have the last, it probably was my fault. I just have to check one more. Yes, where is this? It's a part where the organization of the course and requirements is written, and you will find an exam topic list, but actually claim what type of questions will we have. Looking now at these questions, and just remember, have we discussed the laboratory equipment and laboratory methods and biochemical devices? Just don't remember, because I mixed two groups. Because in Ortus you have this part. Oh no, you doesn't have. Probably we have not discussed it, so I actually have to present one more lectures about the chemical analysis. So probably we will have not. Did we discuss it or not? I guess not. Because yeah, chemical analysis, biochemical analysis. No. Okay, so it means that we have still two until this 14th of June. We still will have two classes. Why we actually to continue work in June? Because of our problem with this practical placement. As a practical works with the laboratory works, so we actually try to push as more as possible to the we actually plan all our laboratories, practical laboratories, in the next semester and the second part of the course, and it will be most oriented in the laboratory placement. And then I just to continue to work a little bit, and we actually have to have more classes than 4 per week. But it was planned taking into account that we have prolonged semester because of this epidemiological limitations. So that's why we actually continue to work. Still, we will still have to. Pardon? Is it fine now? Okay, it means that I pulled my microphone. So let's go further and discuss some other examples. Oh, if you don't have these lectures on if you don't have the lectures on the biochemical analysis, so probably we will take some today. Well, so wait a minute. Take a look at one of the. Too long. Okay. And it's a transducer, but they have no chemical. Okay. It's clear now. This is matrix, fiber optic device. Okay. Yes. So actually, and I'll have to add this gem lab to the top. Well, I'll add it after the lecture. Well, so let's go now to our Arduino simulation board. Please open it and we discuss some other examples. Actually, the goal of this training to demonstrate some feature how do we use Arduino for the communication with a computer and for registration of the simple simple analog information. So that's why it's quite short now, a quite short introduction. First of all, before we will continue with the measurement of the digital information, I remember that we discussed how to last time. We discussed how to read the input, digital inputs, how to control digital outputs, like a light emitting diode. We discussed some strange blinking programs, how to write second blinking program on how to. It actually this blinking was a more comprehensive, well, actually more useful example. It's not just for blinking, but if you need some process that happens from time to time. So this approach, what we are using to make the diode blink, may be used as well. So for instance, you need to have some operation, some procedure made every or performed every certain amount of time, after a certain period of time, and you may control this timing with this example how we did it in our former case. Another thing what actually I have to add. Yep. No, not. I have not yet. I have not shared it yet. Yeah, it's correct. It is not shared yet. So now I share screen. I share my screen, and well, so today we actually continue to work with this with our program, but actually one example what I forgot you to demonstrate how to operate light emitting diodes with a different brightness. I remember that we have not discussed it. I forgot about it, but it's quite interesting, not just as an example, but it's quite useful thing. Indeed, if you need to make some indication, or another way, it's one of the methods to disseminate, or to not disseminate, but to control some analog signal using Arduino. The example what we need, you may open it from original. Let's go to the original Arduino application and open example from the basic set of examples which named fade. Probably we discussed it a little bit shortly. Yes, maybe discussed, but I want to come one more through this topic about this fade example, because this fade example, I used this fade example, I remember now, to demonstrate this approach how we can make some value grow After that stops and then go down, actually fall down up to some 0 level. So in fact, here in this example, we have such a code that we define. First we define the parameter which is named brightness, and this parameter indicators actually will be related to the brightness of our LED emitting diode. And then we define the parameter, what we may name it step, or here it's named fade amount. It's actually the amount on which brightness will be changed every step. And then we declare, so in a setup mode, the third parameter in this, the third variable, global variable in this code is just the number of the LED leg, what is connected to the LED. It's a number 9. And we declare the pin mode of the corresponding leg as an output here. And then in a loop, we actually use here a special one of the functions available for Arduino, so-called analog function named analog write. The analog write as an argument requires a number of LED, so it means at which leg at which output on Arduino, a number of leg, which we actually, or number of input, or output of pin, a number of digital pin, what we actually used for output. And second, it's a value of brightness. For the analog write, the brightness may be in a range from 0 to up to 255. So it means that the value of brightness is coded in 1 byte, so 8 bits, and the maximal number of different levels will be 256. So the corresponding value of brightness may be in a range from 0 to 255. Well, so what actually this analog write is doing? Analog write may control some pins, some digital pin of Arduino, and those digital pins what may be controlled with this analog write analog write function is marked, or is actually marked here on the board and in the documentation with this tiled symbol, with this wave symbol. This symbol means that corresponding pin may be driven with a pulse width, or may be used to drive a pulse width modulation signal. What the pulse width modulation means, I hope we discussed or not, but I try to show it in a small, just to provide some illustration. I don't use some special tools, I just try to show. So for instance, we have some pulses. Usually in a pulse width modulation, we have a pulses. So the pulses, they actually, if you have some rectangular pulses, is it fine with the thickness of a line? I guess so. So we have some pulses. Let me make it more. For these pulses, we define the time of single pulse, of one period time. So it's a period of our pulses. So it's a period. We may generate pulses which takes different part of the period. So we may define here as well. This will be the pulse duration, and actually this will be the pulse duration. The value, which is a ratio of pulse duration to the period, is usually named as duty cycle. It's a duty cycle. So what does that mean if a duty cycle is 50%? There's a half for the pulse duration is half of the period. So if we have a duty cycle 50% or 0.5, so it's just the length of the pulse is the same as this. Actually, it's half of the period. But we may generate a different type of pulses, and among all others, we may change the pulse duration. So we may alter the pulse duration, so we may have some, for instance, some shorter pulse. Sorry, we may have some shorter pulses like this. Something like that. Yeah, so we will have just shorter pulses. In this case, the duty cycle will be lower, of course, and the duration of pulse take less part of the total. We may take a longer pulses as well. Yeah, we may take a sorry. We may take longer pulses like for instance this. And then the duty cycle will be bigger than 1. So generally we could understand that the duty cycle may change from 0 or nearly 0 up to 1. So when we have 0, we actually have the low level of signal, so just 0. And if we have 1 duty cycle, it means that all the time, all the period, we have just a high level of signal. So, and if we consider that the pulse duration or duty cycle, better say the duty cycle, and duty cycle is some function on our signal value u, okay, let's say some voltage u. It's some function of our signal. Then we may actually use the series of pulses to provide some or to carry an information about our signal u. So we may, for instance, make this duty cycle, this pulse duration just proportional to the value of signal. And this type, in fact, this signal, which consists of pulses with a certain repetition frequency, so let's remember that 1 divided by t is a repetition pulse repetition frequency. And so we have some pulses with a certain repetition frequency, but the length, the duration of the pulse is actually altered, is changed. It's changed independent on our signal. And this provides us information, this actually carry out information about our signal. So this type, when one signal carries some information about another signal, so then we say that this first signal is, or first carrier is modulated. So we have some kind of modulation. We may remember analog modulation like an amplitude modulation, when the amplitude of the carrier signal is some certain frequency change corresponding to the values or changing of the carried frequency or carrier signal, or we may remember the phase, the frequency modulation, and the frequency of the signal change in accord with the inscribed signal. And here we have the pulses which width or duration is changed in accord with the inscribed signal. So, and this type of modulation is named pulse width modulation, or PWM. So for Arduino, for the case of Arduino, these outputs, what we could see here, they may be connected internally to the internal source, pulse sources, which operates, if I remember correctly, for the Arduino Uno and Nano on 5 kilohertz. So actually these pulses in Arduino comes with a frequency of 5 kilohertz. 5 kilohertz. For Arduino Duo, I guess it was even 10 kilohertz, but never mind. So we have such kind of actually high frequency pulses. And these high frequency pulses may be, the duration of these pulses may be modulated. If we take these pulses and connect, if we provide such a pulses of voltage on the output of our Arduino and connect a LED emitting diode to it, we generally doesn't see this blinking at the frequency of 5 kilohertz because of inertia in our eye. But the duration of pulses will be changed. And what happens? What happens if we actually change this duration? Let's consider how the LED works. So when the pulse is on, the LED will be switched on a maximal brightness, and when the LED is off, when the pulse is off, the LED will be switched off. So actually, here, somewhere here, we do have the LED operational, and here we have a LED operational too. But the total, if we take the total amount of light, which is actually or our average amount of light, which is produced over the single period of these pulses, we understand that this amount of light will be actually proportional to the area, to all the area of my pulse, of our pulse. So I actually have to take this area and divide it by the total duration of the pulse. So we understand that if I have one short pulse, the average level will be something here, will be quite low, somewhere like this. But now this red line, this red horizontal line, it actually cut from the bottom the amount. Actually, this line, I approximately draw this line to have this total surface to be equal with the surface or total area of the all the underline to be equal to the total area of the pulse under the pulse. For the higher durations, we certainly will have a higher average number of photons per one period. As this process happens very fast, our eye just doesn't have enough time to react on such a fast changes, but we perceive an average number of photons that comes. And this is a way how we may control the brightness of the LED, because it is impossible, it's very difficult to control brightness of the LED just by playing with the voltage. It's quite a bad idea, because usually LED either is on or it doesn't provide any light. So because LEDs are highly the brightness of the LED it actually depends on the current through the LED, but current is very how to say is very in very linear manner depend on the voltage. So if I try to draw the dependence of current over the voltage, so I have to remember, yes, that for diode these dependencies look like this. So it's quite non-linear. So we have nearly no current for certain range in a voltage. So that's why it's not convenient to control the brightness of diode using just changing the current. It's much more easier to provide this diode to operate in the mode that is open or closed. Yeah, so even it's on or it's off. Yeah, and then when it's on, so it provides maximal brightness, and we just play with the duration. So for the Arduino, this duration of the period actually duty cycles, all the duty cycles valid from 0 to 1 is coded with this 1 byte of data. So it means it's coded with number from 0 to 255. So when I put 0, I have nothing. I just 0 level, no pulses. When I put 1, I will have just totally all the time. I have 1 on this output, high output, and no pulses too. So this is actually the how we may control the power of the light emitting power of LED. This pulse width modulation is suitable not only for the light emitting diodes. It's suitable for any type of light devices. So when we are trying to dim some light, we may do this using a pulse width modulated signal, because the inertia of the thermal process for instance, in a filament lamps, usually it works with a filament lamps. It's may work poorly with diode lamps, or with diode lamps it's fine, but you have to have very high frequencies, and it will be fine. If the frequency is low, for instance 50 hertz, if you provide these pulses with a 50 hertz and try to use this pulse width modulation approach to, for instance, to control the brightness of the light in a room. So for the lamps which are filament lamps, such kind of regulation will be fine. The inertia of the filament lamp actually will not provide noticeable blinking. But if you try to, and there was some such appliances which allow you to regulate the brightness of the light in your room, but they are usually thyristor based, and actually what they are doing, they convert 50 hertz current into the pulses of the different duration, just by switching on some thyristor and regulating some thyristor. So when this thyristor switch the voltage on, so it will be open and then switch actually switch switch a voltage on the lamp on. So it's working like immediately like in the blinking mode. For the filament lamp it's fine, because the 50 hertz in time between two consequent pulses at 50 hertz, it's enough. It's long enough. It's short enough if we compare it with the thermal inertia of the filament lamp, but it's not enough to the fast reaction of the LED lamp. And if you use a LED lamp with such type of regulator, as it works at 50 hertz, you may notice the oscillation. You may not notice blinking. 50 hertz is too much, but it actually will be very bothering for your eyes, because of this blinking of the light at the edge of sensitivity. So we barely could see that, yes, indeed there is some blinking, but at 5,000 hertz and 5 kilohertz, this is absolutely fine, because even LED become too inertial to react on such a high change in such fast changes. Well, so okay, and finally, so the conclusion is that we may use this pulse width modulation to control not only diodes but also a filament lamp. We may control using the pulse duration. We may control heaters, and it's much better to control heater using pulse width modulation than use some kind of additional resistance, which actually which takes a part of the power from the heater. So for the heater, the best way to control heater indeed is pulse width modulation. And most of the automatic regulators just use this pulse width modulation to control heaters. So with this pulse width modulation, you may smoothly change the average power what is distributed to heater. Another example of not only heaters, but it's may be used to control DC motors. Pulse width modulation may be used to control not step motors, but just the DC motors, which average momentum depends on the current, average current which is flowing through the coils of the motor, through the rotor of the motor. So it's quite a widely used approach. And one more for the Arduino, so these outputs, which has a that has this tiled wave symbol is available for the pulse width modulation, and the value in such case is written inside to the corresponding output using the analog write, not a digital write, but analog write function. The processor will understand by themselves whether it's whether it's correct pin or not correct pin, do it by their own. And the difference, if you connect it, try to use this analog write to the non to the pin that doesn't support this pulse width modulation, you will just get either 1 or 0. It will not communicate some error. And you may see next, what you may see from this example is this construction with a if function, if which check whether the brightness is less than 0 or brightness is higher than 255, then the value of this fade amount, or amount what we actually are adding all the time to the brightness signal, will be switched to the negative. So it's actually very simple way to force the value to grow up to a certain level and then to decrease up to a certain level. These levels are these parameters in the comparison operator. So we compare with the lower level, and if it's lower than lower level, then it means that we reached the lower level and have to move back. And here is a higher level. And the same, if we reached the higher level, we couldn't go over. It will overflow corresponding registry. It should go back to 0. So then changing the amount sign from minus to plus, we get the growth for the next couple of steps in the loop. And additionally, here is just a delay for us to be able to see that indeed there is some dimming effect. Now let's try to use such program. So it was. I just don't want to write all the code manually. Prefer to open it. Oh, load. So, hello. Yep. So I download this fade. And this fade actually refers to the number to the LED number 9. And I will take this LED and put it the LED number 9. Let's just check whether the fade will work from simulation. I'm afraid it may not work because let's see. No, yeah, as you could see in the simulation, it's not a normal fade. It's just like fast blinking. So either it's seen normally without blinking, or it blinks with a different frequency. So unfortunately, in simulation, we couldn't demonstrate or see well how the fading algorithm works. Well, okay. So I'm nearly speaking about 45 minutes. So let's take some short 10-minute break now and then continue. Okay. Okay. Oh, okay, let's continue our examples. And second, and then the second part, what I'm just going to demonstrate, it's an operation with an analog signal. In our simulation, environment, we have here some of the controls around that may be used to simulate an input analog signal, and one of them is these two sliders. The first one and the second one. So this slider actually provides the output voltage in the range from 0 to 5 volts to the predefined input. Arduino has a 6, and Arduino Uno has a 6, and Nano has 8 analog inputs, which are indicated from A0 to A5. And we actually refer to these inputs using this indication A0 to A5. Let's open another example in original Arduino book. It will be in the basic 2, and it's named analog read serial. Actually, this is what we this is actually what we need to see how could we read an analog signal from the output, from the analog input, and do. In this case, we just send this value via serial port to the computer. So let's see what we have in the code. There is nothing special, nothing separate variable defined before this setup program. This setup contain here just initialization of the serial communication port, and all the business happens in the loop routine. So we don't need even assign analog input to any output or input, so that by default, without any pre-programming, it's already configured as input and analog, more or less, moreover analog input. So we just read the analog value of analog voltage attached to this input using the function analog read. And this function return integer value, and we just assign this integer value to the variable that we name sensor value. And then we just print sensor value, and it's generally enough. And it's all. Let's try to copy this code, or even I probably even write it down in our code just manually. So I don't need to make this code more clear. I don't need all this definition, and I just need setup mode where I define my serial port at the communication rate 9600 baud, and I use the output A0 to read out data. So here I just write that my integer sensor value is equal to analog read small k, it's Java style, analog read from the port A0, and then just print sensor value. That's actually all, nothing else. I don't need anything else here. Only way usually to have more stable operation of analog to digital converter, we usually add some delay, but not big one, just 1 millisecond. So, and this is a delay So just analog to digital converter needs some time to make a conversion. So this delay just usually required to give this time to the analog to digital converter. And with this delay for the next time, ask this ADC output for the analog digital converter for output, the data already will be ready. Otherwise, you'll have to wait for them. Generally, the use of standard analog read function is not the fastest one. If you need a faster operation of the analog, faster reading of the analog input, you actually have to work directly with the registers of the registry of the controller and read the data directly from the registry. But there may be some problem related to this, that data will not be ready yet. So this built-in analog read function provide not only just read the data, but it validates the data. It checks that indeed the analog to digital converter stops conversion, that the data is ready, data is valid, and that it takes additional time. So for the very fast reading, we may read it directly from the analog to digital converter output buffer or output port, but without any validation. But then we have a risk that the number we got from this buffer will not be an accurate result of the translation. Let's see now. Okay, let's compile this. I compile this code and accept it, and let's try to initiate this code. But I just have to declare which one of those slider I will connect to the input A0. No, for example, this one. So let's run our code and see here on what is in the serial, what is what is given into the serial port. We may see blinking sensor value here in debug window too. So at the moment my slider is at the very low position, at the bottom position, and then I have all the zeros. If I pull it a little bit up, so I will get some number, 233. Let me go even further. You see the number become even bigger, and then finally I may take it as big as possible, and you see that the number ends with 1023. So it actually just demonstrates that our analog digital, the ADC converter in Arduino is 10-bit converter, so it has 10 bits, and the maximal number what we could represent with the 10 bits is from 0 up to 1023. Generally, we may work simultaneously. For example, we may work simultaneously with 2 digital input. So what do you think we have to do? Oops, sorry. What do you think we have to do if we're going to read a signal from the second input? Yes, we need to use another input, for instance, sensor value 2, and read an analog read from other input. Let's take A1, yeah, but we may take A5 too, for instance, or A3. No, I will take A1. And if I wish to print it out, so I just print it out. For this example, will I get the 2 column of data? No, I will get 1 column in which the sensor value from the reading of A0 will be first, and the next will be sensor value 2. But they will not go in 2 columns. To go in 2 columns, I have to use print here instead of println, because I don't need my cursor jump to the next line. So I print first value, then I have to print some separator. I will use a tab this time. Here what I read here, I read backslash and the T letter. The backslash in the expression concerning with the print and strings expressions. The expression is contained some text, some strings. This backslash is a special symbol that indicates that the next letter will be some code. We have a different kind of type of these codes. One of the codes is backslash T, which insert a tabulation in a text, in a string. So when our serial monitor print out the bytes or symbols, what we actually send to be printed in the serial monitor. So then when we get this slash T, the tab symbol will be printed. The same I may write here another example of such type of such kind of symbols is sorry, what I forgot that this is actually text. I have to put it into quotes. And for instance, the very popular command /r/n corresponds to two invisible symbols. R is a cartridge return, and N it's the next line. So the cartridge return symbol moves the cursor back to the beginning of the current row of the string, and next line just moves the cursor to the next line of the text. These symbols comes from the history, because such buttons, or let's say controls, was used in the typewriting machines. So they have to press one button to go to the next line and turn a special lever to return the cartridge back to the beginning of the text, beginning of the line, And these symbols came from this historical typewriter design and typewriter control. So they are used very often. They use it together in pairs, /r/n. They are used in pair as a sign of the end of the line. And please note here that I wrote a print, those not print ln, but just print. Why I may do this? Because print ln is actually the same as a print of these /r/n symbols. So when we use a function print ln, then these two symbols are invisibly to us, to users, added to the actual string and sent to the serial communication port. Well, so in this case, I will get what I want. By the way, just a question. What do you think this symbol means? Two backslashes. If I put some two backslashes in a text, what do you think will be sent? Backslash itself, yeah, because the backslash is a symbol, a sign of that the next symbol will be some kind of command, some kind of instruction. So that means that we just couldn't include just a backslash in a text. Yeah, we have to add two backslashes. We actually have to add two backslashes. I get the same will be backslash quotes, like this. Allow us to print out just usual quotes, because if we just put a quotes or a single quote or double quote in the text, the computer, the controller or compiler understands that this is the text, this is the end of the text. So if we are going to put the quotes in a text to be printed as a symbol of quotes, not just as an indication of the boundaries of our text. So then we need use backslash quotes to get it. So it's quite typical to many programming languages. So, and here, let's see what we got now. So I compile it. I hope it will find and accept it, and then I assign the number A1 to the second slider. Let's run our program and Oh, yes, and here you see that we have now two set of data, and they are actually uh, uh, both reacts on the value of the positions of the slider. Well, so we may use the position of the slider to control some internal processes in our uh, code. For instance, let use for example the first slider to control the frequency of the blinking, how fastly the LED is blinking. So we may do this, for instance. Yes, so if 0, it doesn't blink. If it's 1, it's no. It's actually we need to define now to invent how what type of control, how do we actually control our blinking of our LED. It's better probably, well, we start not with a blinking, we start with this fading. You see that in our simulator, the fading is not working very properly, and instead of fading, we see some kind of blinking. But if we imagine that instead of our simulator, we will have a real Arduino with a real LED attached to it, so we will see the brightness, how the brightness of the LED is changing. So we use the same approach. But what is here so we actually, if we're going to use our sensor value to control the brightness of the LED, first of all, what should we do with this value? So, okay, let's imagine now I wish to use. I go immediately to the code. So let's see the code. So I wish to use my sensor value of what I have got from the slider, sensor value, to control brightness of the LED on the pin number 9. Yeah. So for this, of course, I need, first of all, I need to define to define my pin number 9 as output. Yeah, so it's fine. I defined my pin number 9 as output, and then now I wish to control the brightness of this pin using this pulse width modulation to control the brightness of this pin with my signal sensor value. May I write something like that? Something like that, analog write 9 pin. What do you think? May I write like that? That looks at our example fade. Yeah, exactly. What should I do actually? Okay. So you actually already provide some receipt. How could I manage it? So I actually have to recalculate. In other words, more globally, I have to recalculate my range of sensor values into the range what is acceptable for the analog write. Yeah. If I remember correctly, we have some special function in Arduino, and this function, I'll try to find it now via help. Let's see references. And it should be some function what is named map. Try to find it. Probably I will not find it immediately, but it was such a function in Let's write Arduino map function. So we have indeed such a function. So Arduino has such a function. In the mathematics, function map. So actually, what it do? Does the function map do? It's an integer function. What is interesting? It's an integer function that actually takes some range function, some value in one range, and recalculate it into another range. So if we look at this function, so here you could see an example how we actually yeah, so the arguments of the function is to remember. Yes, here is it. Yeah, here is the syntax of this value of this function. So we actually have to provide a value what we are going to recalculate. This is a range, lower range and higher range of this scale of this value, and here is a lower and higher range of the value we are going to recalculate to. In fact, we may use this map function. So let's use this map function. So I will introduce integer value brightness that is equal to map, and then provide this mapping. So actually, what should I convert? I should convert sensor value from the range of 0 to 200 or 123, 1000, sorry, 23, to the value set to the range of 0 to 155. So I may use this already. I may use this symbol, and then I use analog write with this brightness. Let's compile. Okay. Oh, sorry. Yeah. This way. Now it's fine. Accept, and let's see let's see indeed what happens. Yeah? So now when I move my slider, you see that my red LED here, start blinking because this blinking is related to the brightness of the LED. So instead of having a certain brightness, it blinks, and so on. And I may try to write more complicated code to alter not a brightness, but the delay what I actually may have for like a blinking rate. Let's try to write code that change the blinking rate independence on my on the position of my slider. We go back. So for the control of the blinking, let's remember how we do this blinking. So I will introduce some additional global variables. At status, which is Boolean lead status, which initially is false. Don't like this. Well, false. It probably should be. For the constant. Okay. Well, I may use false and true too. Record. Please see here. Just false. Usual false. And then I define. Okay. I will have done it in a last time, old time. I'm sorry. Long old time. And And generally, I may define already scale 0, and I may generally define some unsigned, maybe actually integer duration, which will be a duration of the let's say half of the let's say blinking time. So we use this duration. So duration will be time during which the LED will be either on or off. So it's actually duration. It's a half of the period. And then with duration, it's not necessary to be now to define this duration because I actually define it every time. Every time I will measure my input, but I may define it just for any case. Let's take 100, no, even 100, 2000 milliseconds. When here in the setup, I will define my hold time as a number of current milliseconds in the internal timer. And here I actually need, now I read my analog read, and then I have to redefine my sensor value into or recalculate it into the delay. So let's take, we actually still, yeah, I will take my delay duration. By the way, it's not necessary for me to define this duration here. So I define int duration here. It will be equal to, and then I have to recalculate the sensor value from the same range from 0 to 1023 into this duration. Now let's take such an example. If my input voltage is 0, the blinking will be, for instance, twice per second. Twice per second. Sorry, for instance, 1000. And when it is maximal at 5, let's it blink, let's say, no, I think we don't see we don't see blinking at more than 10 times per second, but let this duration will be just 0. So it blinks actually every time. So it's we see it as it's actually will be on all the time. I think we have to see it. So please note that I made here inverted maximal and minimal value. And then, so if millis current time minus hold time is longer, greater than duration, what should I do? I should do two things. I should invert or take negate actually LED status, and second, I should assign a new value of hold time using current time. and write down the new let status. Actually, I don't need any more here analog write. Now let's check what we got now. It should actually, I hope it should work. So let's compile it, accept it, and so now we see that our LED is blinking approximately, it's on 1 second and off for 1 second. If I move a little bit my slider, you see it's blinking faster. And here you actually may see how the duration is calculated. And if I move it even faster, it's blinking even more faster. Yeah? So the duration is approximately 0.2 seconds now. And up to maximal, and duration is 0. It's actually blinking very fast. As fast is operation of our, as fast is the operation of our simulator. So we see this blinking probably just because of the simulation of because of the finite velocity of simulation. It works a little bit slower than original Arduino. So, is it any question up to now? Generally, if you look at this map function, so could we replace this map function with some mathematical calculation without maybe we do the same without any special function, without special map function? So okay, yes, generally what do we have? So we have a from min value, yeah, and we have from max value. So this is a range of input value what we wish to map, and then we have to min value and to max value. Yeah. And then we have value of x. This is a value in the range between from min to up to from max, and we have value of y, what we are going to recalculate. So now let's try to write equation. How do we recalculate y, x to y, without using a map function? So please, you had some idea how to do this. No. So I have, let's now just understand what do we use in this map function, how this map function calculate this value in a new range, this y. So we actually had y, x. We had x from 0 to 1023. And in my example, not in this example with brightness, but with my example, we got an y, which is now in a range from 100 up to 0. What important is that higher y corresponds to lower x. I just want you to find or to probably remember or to get what is this recalculation formula, what is the equation, how we recalculate y into x into y. Okay. So actually, I have take something like this. I take some difference from max minus from mean. Yeah. Okay. Now, please be careful. What should I divide? Should I divide difference in from or to the differences in two or differences in these two? The thing it doesn't. I prefer, if I've said this, that I prefer multiply. Two should be at the top. Yes, exactly. Because we will multiply it by x, which is the value from. And then from and from will shortens. In fact, actually, what we have to do, we have to write some linear transformation. This is a typical task. It's a task of the scaling. So we have a one scale, and we wish to calculate this one scale into another scale. It's a very typical task when you work with the digital devices. So we scale our data. So, and what I should do with our ratio? Probably I have to multiply x. Yep. Is it enough just to multiply x? Oops, sorry. Yeah, 2 max. Yeah, so certainly 2 max. Is it enough just to multiply by x? Generally, it will be enough if either from mean and or to and to mean, or from mean and to max if we have a reverse. Yeah, if they are both are zero, then it's enough to multiply. Yeah. But if imagine, so in our case, I try to make such a conversation. Yeah, I make such a conversation. Let's imagine if I need to do another conversation. For instance, y will be now. I wish to have y from 1 to, for instance, 5. Or it's even no, not good example. My x, for instance, may change only from 5,025, 525 up to 123. Is it enough now to, and y, I wish to have a y from, let's say, from 0 to 5. It will be enough to multiply just by x. So let's see, the differences in from is 525. Isn't it? No, it's something wrong. Why 525? Not a 525. And 500. Oh, I have to calculate now. Sorry. To 511. Sorry, 511. From 511 to 123. So the difference is 522, 512. Yeah, this difference will be 512. The difference max minus mean will be 5. Will be 5. And if I multiply now by this ratio, if I, sorry, if I divide now 5 by 500, 15, and multiply it by the lowest x, 511. What will I got? Somewhere about 5. Yep. But I want to have 0. What's wrong? And if I take highest 123, if I take 1023, so what will I get? Nearly 123 divided by 512 give me somewhere about 2, and I will get 10. So instead of 0 from y from 0 to 5, I will get it from 5 to 10. What wrong? Why? Maybe I need to do something with x before I start to multiply. So what happens if I first, before I multiply, just take from mean and subtract it from the x initial. So let's see what happens now. So when the ratio is the same, yeah, that now when x is 511, I take 511 minus 511. It gives me 0. Yeah, is it correct? Now, now it will be 0. And when I take 1023 and extract 511, I get 512. This is difference. Will give me 512, and the results will be exactly 5. So I will get what I want. So it means that I shouldn't take just x. I should take x minus this from minimal value. If from minimal value is 0, it's okay. It's enough to multiply by x. And finally, let's imagine that I want to convert my values not into range from 0 to 5, but into a range from 1 to, for instance, from 1 to 6. What should I change? So my 2 minimal now is 1, not 0. What will change in my equation to take into account that I wish my 2 minimal will be 1, not 0? Exactly, I have to add 2 min. So, and this is final. This is a final scaling formula. X actually, it looks now in a maximal form of the linear transform. So we have some slope constant. This is a slope, and we have some intercept constant. But intercept here a little bit tricky. So interface look like sum of 2 intercept looks like 2 min plus actually minus this slope multiplied by from mean. Yeah. So we actually need to make a linear transformation. A linear transformation usually have some adding too, not just the multiplication by some constant which we name slope, but some adding too. And this allows us to convert what this formula actually, this one. This is actually now all pupils. It's all pupils formulas that allow us convert to one scale into another. The question just is why we need to write it. Why do we need this? If, for instance, we have such a convenient function as a map. So what is the reason to write it manually if we have this map? And the answer is that map, this built-in map, is an integer function. But let's imagine that I want to have not the integer output in my code, which actually still continue to print out all the codes what I have here. You see, for instance, I wish for the second sensor, I wish to print out not the number what we read from the analog to digital converter, but we want to have a we want to have this value in volts, like indeed to get the voltage, not just the number which is proportional to input voltage, but we wish to have a voltage to be printed out on the screen. So what should I do? I should remap my numbers, which are from 0 to 1023, into the voltage values, which are from 0 volts up to 5 volts. But if I do this using a map value, let's try to do this using a map value. Maybe you already may say what I will get if I use a map value. I will get just 1, 2, 3, or 4, and 5. I will not get the values in between, and it's obviously I lost too much information because of this. Because my values are I have different 1024 different level of signals, but all this level of signals reduces finally into just 5 level of signals. I wish to work with the float numbers. And for the float numbers, this map function doesn't work. So if I wish to convert my ADC values X into voltages, so first of all, I have to work now with a float or double variables, because it will be a floating point numbers. But second, I have to make this conversion. And my conversion now looks like this. So my original X is from 0 to 1023, but my output should be from 0 to 5, as it was in my first example. And this is very nice, because from min and to min, both to min and from min, they are now zeros. That's why in my formula, final formula, so if I write them down, yeah, if I take my formula and try to rewrite it as I need, yeah, to min will one-ish because it's 0. From min will one-ish 2 because it's 0. I just get X. And here to min will one-ish because it's 0. And from min one-ish because it's 0. So finally, I'll get just 2 max divided by from max, what you actually suggested in the very beginning. Yeah? So you actually already suggested to divide one to this another and then multiply by the value. Yeah? But see, this case, it's just a particular example of the previous formula for the very particular conditions when we have the scale in the same way, in the same direction. So the maximum of one scale corresponds to the maximum of the another scale, and minimums are corresponding to. And second, that the origins of these scales are 0. For the first scale, origin is 0. For the second scale, origin is 0. Here and then of course we have a much simpler representation. So let's implement it immediately for our sensor, in our code for the indication of the second sensor. So what actually should I do? I will not use now map. Yeah, I calculate here. I will do it beforehand. Okay, somewhere here, I will just introduce a float voltage, a variable float of the type of float voltage, which should be actually 5.0. Using this constant in the form of 5.0, I immediately show to compiler that I will work with the float numbers. If I remain 5 divided by 1023, so when the compiler find this node, it take 5, considers that 5 is integer, divided by 1023, what it considers as integer 2, and the result of this division will be, would you guess? But yes, it will be integer, but how big it will be? Yes, exactly 0, because 5 divided by 1000 will be something less than 1. And if it's less than 1, for integer it will be round up to 0. Yeah. And that's all. So that's why to show the compiler that I will work now with a float. And why it happens? Because the compiler doesn't look at what type of result it will have. It starts calculation from the reading this expression. And when it reads an expression, it reads it from left to right, symbol by symbol, and element component element by element. And first element, what it see here, it's a constant 5. And it's take its constant 5 and look, okay, there is no dot. So it means it's in integer. Then it's found, okay, divided by something. This something is integer 2. So I take one integer and divide by another integer. By default, it doesn't look yet on what type of the variable it is. It's just take two integer and divide it by one to another. Then it see second sensor value and it look, sensor value, fine, it's integer, record sensor value. Look here, it's integer too. It multiplied by integer. And the result will be integer, but because the rounding, this rounding, okay, but calculation comes from right to left, so the first operation immediately gives us 0, and that's all, and I will get 0 in all the results. What should I do to prevent such a behavior? One of possible cases, it's just take 5 multiplied by sensor value first and then divide. But anyway, it considers that this is an integer because first constant at c will be integer, and only after it's made its calculation, and the calculation are in memory, it's take a look, I should to assign the result to some float variable. It converts result into the float format, how the floats are kept, and keep it in the corresponding memory, in the corresponding memory address, memory registry, as float already. But the mistake, this type mismatch mistake, will be already made. That's why the calculation result will be 0. Okay, and then I read down not a sensor value, but a voltage. Oops, sorry. Voltage. Well, compile and accept, and let's look at our code. And as you see, indeed, now this number in the second column is a floating type number, which is actually corresponds to the voltage. It's already is recalculated. So such kind of recalculation always should be done, and we have to bear it in mind. Yeah, that we need to perform such a scaling. Another type of scaling, what is worth to discuss, generally. First of all, speaking about Arduino itself, so one of the input of the Arduino, so RF, you could see it here. It's before the ground, RF, analog reference. The scale of voltages what Arduino is working with depends on the value of this RF. If we leave this RF unconnected, then the scale of voltage for the input analog input signals in Arduino will be from 0 to 5. Actually, it's from 0 to the power supply voltage, but it's internal power supply, it's 5 volts in Arduino, more or less, plus minus. If we need a very accurate voltage, it's better to attach some stabilized voltage source to the RF input. We attach it to the RF, and then the range, input range of the voltages what Arduino could measure will be from 0 to RF. So if we take it RF equal to 1 volt, then we get a voltage range from 0 to 1 volt. So you should to remember, yes, that if you may control this range. And when one more, it's required when you are really looking for the very accurate ADC conversion, very accurate measurement, and when you wish to be sure 100% what is your reference range is. For Arduino, it's dependent on particular, they use actually more or less accurate voltage stabilizer inside. They're more or less accurate, but still there is some differences. There may be some differences in one stabilizer from another, so they a little bit difference. And then this voltage not accurately 5 volts. It may be 5.2, 49, 4.95, 96, or 5.1, 5.12. So they little bit shifted from this 5. It's not exactly 5 volts. And if you need an accurate, so please don't remember to attach some certain accurate voltage source to the RF. So this is the one aspect. Another aspect, actually, when we work in future, and when you make your project, we will be forced to connect something analog, some analog circuitry to the Arduino. And analog circuitry, what we will have, so if I have some amplifier, so let's imagine I have some amplifier with some inputs, no matter what the amplifier it is. For instance, it may be ACG amplifier. They finally, it's not an operational amplifier, just try to draw a block scheme. So I have some ACG signal, yeah. For instance, ACG signal, on some other, on AMG signal, but most of the biological signals are bipolar. It means that they look like this. So I draw something which is close to the ACG. Yeah, probably you even recognize it from your physiological course. So we have a bipolar signal. What does it mean? So it's change. It's actually is altered from some baseline, which is 0, which is our signal 0, the baseline, but it may be both. So I have a 0 somewhere here, but the signal may be both positive and negative. And actually, nearly every biological signal finally is bipolar. It means it may be both negative and positive in respect to some 0. When we have an Arduino, so the Arduino usually has power supply from 5 volts and somewhere, and it has some ground input somewhere here. The corresponding analog input, from, let's say, A0, accept the voltages in the range from 0 to 5 in respect to the Arduino ground. So it means if I connect something to the input A0, so the voltage here may be from 0 in respect to the ground up to 5 volt in respect to the ground. There is no room for the negative voltages originally. So we have originally no negative voltages. Yep. And how we usually design our equipment in this way. So if our amplifier has a ground output too. So we have here some ground or common electrode. So we have ground here. So we have two grounds. So analog ground and a digital ground. We have these two grounds. And the signal which goes out of the amplifier is unipolar, is bipolar, both maybe negative in respect to ground and maybe positive in respect to ground. That's why before we connect our Arduino, our amplifier with Arduino, we need to make a shift. What we actually is doing, we artificially shifting this zero level. More accurately to say, so we actually add some constant voltage to the output signal to shift this output signal above the zero level. So to have all our signal to be in positive range. So here somewhere inside, we will still have so-called, let's name it analog zero. So it's analog zero. It means the voltage level what is corresponding to the zero biological signal. So when the biological signal is zero, we have no biological signal. The output voltage of this shifted signal will be at this level, at this level of analog zero. And all the analog signal, all our analog signal is oscillating or moving or changing in respect of this zero. So we shift all the scale. And then it means that all what comes to when we're going to recalculate, when we're going to recalculate our original, our signal, our values what are obtained from the analog digital converter, which is in a positive range from 0 to 1023. So we have to take into account that all our signal is shifted. By the way, it's not a big problem. It's actually not a big problem. So for some typical example, so to match Arduino with analog part, let's imagine that analog part is powered with a power supply plus 5 volts and minus 5 volts. And minus 5 volts. So actually, all our signals is in a range of plus minus 5 volts. So when we, for instance, when we shift our signals, so we find such an amplification coefficient that guarantee that the range of our signal will not exceed this 5 volt and just add 2.5 volt to our original signal. So as a result, so this distance or this voltage is 2.5 volt, and this range is 2.5 volts too. Oh, I probably have to shift both this signal a little bit up for them to be more symmetric. So I actually just add 2.5 volts to my original signal, and then the output of my amplifier will be with the range from 0 to, okay, output of amplifier may be -2, but all my biological signal will be encapsulated in a band from 0 up to 5 volts, and the level of or let's say, and the absence of signal corresponds to the DC signal at the level 2.5 volt. In fact, what we actually, when we are going to recalculate, our signals here, we may just map. We may map our signal a little bit different. Yeah. So our biological signal or measured signal actually alters from plus 2.5 volts and from minus 2.5 volts. So all the signal occupy a range from plus minus 2.5 volts. It just means that in this equation, in this our scaling formula, our input signal, or not scale it, ADC signal is from 0 to 123, but our Y signal will be from minus 2.5 up to plus 2.5. And then by this way we provide the correct scaling. Indeed, the number what we recalculate, yeah, when there is no signal, no like biological signal which is equal to 0, I will get 0. Yeah, and for the positive, I get positive value. For the negative, I get negative value. Please take such type of scaling into account, that we often specially move our signal into positive range and operate only with a positive range to be able further to combine the analog part with the digital part. So this will be an important thing in our next semester when we try to design our own measurement device, biological measurement device, biosignal measurement. Well, okay, so this is probably all what I want to discuss concerning the application of the analog grid. Some other example, let's I just use it. I may use my signal to control, for instance, another LED. I add another LED, which will be just let it will be LED number 10. I will define it, define pin mode, and an output. And I want what I want to do. I want to add such a condition here additionally, for instance, that if a voltage greater than 2.5, I just write in 9 pin, and then pin, sorry, high. I just switch the LED on, and else let it will be low. So actually what my code do now, so if voltage is high, it switch the LED on, and if it's lower than 2.5 volt, it switch it off. Let's compile and accept, and look how it works now. Stop, sorry. So I have to assign here a 10, that number 10, and write it down. So indeed, so when I have higher than 2.5 volts, it's switched on, and then it's switched off. Well, so actually it's all for the today practice, and it's actually all for our Arduino practice, because we take, as I said, we take at the very beginning without any advanced techniques. And next, what we actually will, what we actually will do, we continue this lecturing, and with an Arduino. So this is a small introduction, because we, as fast as possible, we try to come to the combination of our device, our measurement circuitry with an Arduino to get the data in the computer. And the next semester we will consider another example of coding program. We try to work with a LabVIEW program too, to learn how to make a virtual instrument, a very simple virtual instrument, which may operate together with our Arduino. Yeah, but it will be next semester, because unfortunately you couldn't install your LabVIEW in your computers. So it's our license doesn't allow to LabVIEW to be installed in student computers, so we will be forced to work in a lab. Okay, when the LabVIEW is installed. Okay, some comments. So let's reconfigure now. Let's reconfigure now our simulator and add. We go it through the configure your devices. I just add from small your devices. I add one more LED. Okay, and I remove this one 7-segmented LED and add 3 LEDs. Okay, so now see I have here a 3 LED. I may attach them to the outputs 9, 10, and 11. So please reconfigure your simulation program in such a manner and write a simple traffic light code. The idea of traffic light code what you should write will be that you have to accept or read the position of the slider, and depending on the position of the slider, if the slider is in the lower 1/3 of the scale, switch a green light. If it is in the middle, switch a red light, yellow light, and if it's in the top 1/3 of the scale, switch a red light. So very simple. You will find the task description of the task in Ortus Arduino practicum. It will be as a second code, yeah. And the task is actually due up to the next Monday. So please try to upload it next Monday. So I may. Meanwhile, I'll review your task what was submitted just now, yeah, from the last class, and I hope if you submit it on Monday, I may provide some comment next time in Monday about your code. Well, we actually still have some time, so I just suggest to have now a break. Probably, yes, probably we just finished for today. And the home assignment for you for the week is the second code, and please review the list of tasks, that could be or a list of problems that could be presented on exam. Yep. Oh. Yep. Okay. So I have to. I guess I have to check this first home assignment. You mean? The first home assignment was. The first home assignment was. Forget was types of signal. Yeah. Okay. Now I'll open it for you too. Is it okay for you 2 days? Okay, so from now up to tomorrow. So those who are not made this assignment may use an opportunity to do and made it too. So there is it's most like training. So you have no. I guess it was. If I remember, it was no limit in the number of attempts. So you actually have to train until you get a fine result. Yeah. It's more like a. You had another son, but there is no one has submitted yet, and so I will prepare. I hope I will prepare to the next time the set of assignments you should to go through, and they will be simultaneously like a training in problem solving. I have to check all the assignment what I have done. I have checked partially, so, and I set it up to 26th of May, May 2 up to, yes, so fine. It was one assignment, and the second assignment, if I see, it was actually, so the type of signals, it was an introduction, some small training. It was, I guess, second order some filter calculation. Yes, it was a filter calculation, but I have to check what I have here now. Let's I see. Let's check what I have now here. Okay, this one, yeah. Okay, I will open it too. You know. And there is a third assignment with a third order filter, but it's actually I have not opened it yet. Yeah, I thought I will open it, but I have not opened it. So for the filter, you probably need a little bit more time. 25 of May up to 27 of. So if you could do it within the 3 days, so I open it for the 3 days. Yeah, is it fine for you? It's okay. So 23, 59. Okay. So if someone have not yet submitted it, so please use an opportunity too. Yeah. Well, okay. So thanks you for attention for today, and I think we stopped. Yeah. And next time we discuss the result of your code, and we will speak about the laboratory equipment. Okay. So bye. Bye bye.